Hello everyone. We're making today a TDD coding agent. This was my plan for a while now, and I've had the pleasure of knowing Kent Beck and working for several years with Steve Freeman, and I've often had these discussions about TDD and what is better, code first, stats first, etc., etc. So I'm seeing a lot of these coding agents around, like GitHub Copilot, Claude Code, OpenAI, Codex, and all of them they do have an iterative approach, although it doesn't seem like they rely on TDD. So I was wondering whether we can improve the accuracy of coding agents by writing tests first and following the classical TDD pattern. So let's have a look. The usual cycle. So the usual TDD cycle. Okay, that's fine. TDD cycle is we first write the failing test. Not gonna be that verbose. Then run the test, run the minimum to make it fail, and to make it pass, and then refactor the code. I prefer the form which has 4 steps, and it doesn't matter, I mean, really how many steps. We know, okay, if you write the code, you still have to run the test. The important bit here is that we need to make sure that the test that we wrote is failing. So, and then basically from step 4 we go back to the first step and keep looping until we finish the feature. So essentially, we need to implement this in code. Now, the simplest way to do this is just to write some code and invoke one of the LLMs, like I don't know, OpenAI, and ask it to give us the code back. But I think for this kind of project, the most important part will be the actual architectural decision. How do we, which components do we take? Because there's a lot of little details that we might not want to get into. Depends really how much. It depends on the exact balance between control and code reuse that we want to have. So essentially, let's look at some architectural options. Essentially, we have one possibility here is to code everything by hand. So code everything by hand and invoke LLM directly. So now this might be a problem because there are a couple of steps here, like write the failing test and write the minimum code to pass the test, which need modifications of the existing files. Now, LLMs have a request response pattern. So we send a request and we expect a response. Actually, it's a text continuation. It's a kind of an autocomplete mechanism. It works well with question and answer, with a question and answer pattern, because it's been trained for that. And effectively, we can get an answer when we pose a question. So that's the most basic interaction pattern with LLMs. Of course, there are also chats when you need to maintain the history, but that's not important for us here. So essentially, we can code everything by hand and invoke the LLM directly, which means we will be sending a question to the LLM, to some, I don't know, OpenAPI or Gemini or Claude, and sorry, not OpenAPI, OpenAI, and we will be passing the content of all the files involved. We will be asking in return for the file that we want to generate. So we could either ask the LLM to give us a new version of an existing file and then replace it, or we could ask for a patch, or we could do something. It seems to me that it's a non-trivial problem performing a modification to an existing file, because you want to minimize the probability that parts of the file that should not be affected are not affected, and the parts that are affected will be modified according to the LLM specification. So that we have several options on how to approach that. We can just ask for the entire file. We can ask the LLM to generate a patch file and then apply that patch file through a diff. We can ask it to give us some custom format where we explain exactly how that format works. I'm not really sure how GitHub Copilot does it. I know it's a little bit complex, because even once it generates the code, it does another run through something that looks like an AI and then slowly modifies the file line by line, which doesn't seem very efficient. But I believe, given that they have this solution, that it's not a simple problem. So if we code everything by hand, we need to solve the editing problem, or rather how the LLM modifies the code. And then the other approach, I mean, there are many other approaches, but the two that I have in mind on the top of my head, the other one is to actually use another agent. So use coding agent for individual steps. Essentially, here we're basically, when we need to write a failing test, we're actually going to ask something like Claude Code, okay, write me a failing test, and then we just invoke Claude Code on the command line with the given instructions. Claude Code will modify the workspace for us and give us the result. Okay, this is an external process. We might not have such a precise control over what it does, but it might we might achieve some results sooner. They might not be the results we want, or they might be even better, because it solves a lot of problems that we want, that we don't have to think about. So let's see here. So this is lack of control, but probably easiest to implement. And here need to solve the editing problem, full control over the code. Okay, good. So of course, in between we have all of these steps, like we're running the test and we see it fail, and we also need to capture the failure message so that we can pass it on to the next step. And then this next step, we actually, as part of this step, we run the test again, and the test should be passing. And if it's not passing, then we have kind of an internal loop within this step to actually modify the code until we make the test pass. And then also the refactoring of the code. At every time we refactor the code, or rather when we finish refactoring the code, we need to run the tests again. if any of them is failing, then the refactoring is not a valid refactoring, so we need to pass it again to the LLM to refactor better, to fix the error. Now, even there we have a couple of options. So we could either start from the point where we are. So if we've refactored, or if we've already refactored the code, but some of the tests have started failing now, then we can start from that point and just fix the code so those tests pass. Or we could revert the changes and start from scratch, but somehow keep the lesson learned. So that's another possibility. Another aspect, and I just realized I didn't share the link, so no wonder I'm talking to myself. Let's do this quickly. Live coding a TDD coding agent. Alright. It's not the best title ever, but it explains the idea. Okay, no, not there. Okay. All right. So let's see if this attracts anyone. So essentially these are the architectural, a couple of architectural options. Then we could have others. We could, I don't know, modify an existing coding agent. So for example, OpenAI Codex. Codex is open source. I could modify it to support TDD. Of course, and here we have both control and a lot of problems are already solved, but by far the most difficult. So the difficulty comes because essentially we inherit already a complex code base which does much more than what we need. We're doing this just as a proof of concept. We're not really trying to and let me put the chat window here so I see if somebody comes in. Okay, it doesn't stay on top. Alright, I'll put it on the other screen. So this is the most complex option because we inherit a lot of the solutions to problems that we might not necessarily want to solve in this exercise, and we also inherit the technical debt and all of those things. And I also want to ask our good friend ChatGPT I want to write a TDD coding agent. Can you give me some options for the architecture? I don't want to reinvent the wheel, and I want to keep and do and well, simple, so that I can code it in a single afternoon. Alright, let's see what ChatGPT 4.0 says. Okay. Baseline MVP, test generator, code generator, loop until all fails, blah blah blah, and this seems like our option number 1. Modular planning agent, blah blah blah. Okay, I don't think this. Yeah, these are all variants of this code everything by hand. So let me give a few suggestions here, or rather, I'm not interested in the algorithm, but the actual choice of language, framework, libraries, APIs. Here are the options I've already identified. Okay. Right, this sounds better. Total flexibility, easy to log, debug, and monitor. Perhaps can inject your own retry fix strategy logic. Well, definitely this is something we'll need. Must build everything, including code editing, logic, prompt templating, and iteration handling. Prompt, yeah, that's fine. This is really what we want to do. This is in all of the solution we want to be able to give specific prompts to the LLM, and also to handle iterations like check, are the tests passing, repeat, or these kinds of things. Then use existing agents. Not this, I didn't mean this. Okay, so let's be more specific here. Use a coding agent for individual steps, and this would be called code OpenAI Codex. Yes, that's the one. Right, quickest way. Okay, LLM as a black box. Yeah, a little bit. Built-in memory context, tracing, logging. Okay, that sounds fine. And limited control over how each step is performed. Debugging can be painful. Perhaps modifying behavior often means fighting the framework. And yeah, that's true. Hackathon throwaway prototype. This is a throwaway prototype. This also provides possibility for a long-term project, but I think for a long-term project we should still try to leverage some reuse. Now, modifying an existing coding agent, that maybe this could be something doable. I've had a look this morning at the OpenAI Codex code, so it wasn't too difficult to find the place which would need modifications. There's a coding loop, the agent loop class, and I just need to replace that one, although it seems like the code was very coupled and complex, and yeah, definitely written by an AI. without any refactoring. So yeah, it's not the best code base to start with. I'm not sure about OpenDevin or this other thing, GPT Engineer, which I'm not even familiar with. Oh, that's okay. It's a Google solution. Building a software that builds software. Okay, this. Oh, Lovable. They did it. Sounds interesting. Now, does it have source code available? Is this it? Right, GPT Engineer app. Okay, Anton Osika was this, yes. Okay. Alright, so it's a Python thingy. Create new code. Prove existing code, benchmark, custom agents. Okay. Oh, nice. It has benchmarks included. That's quite useful, although we won't go that scientific. I would suggest we try, I don't know, the Roman numerals exercise, and maybe then afterwards we try something more complex, maybe a chess solver or something like that. Okay, GPT Engineer. Oh, GPT Engineer is now lovable. Okay. And what is lovable? I've heard about it, but I've never used it. Documentation. Is this just an API? What? No, these are docs, so I'm really expecting a little bit more here. User guides. Okay, seems like, let's see, is there anything like this? No. No, this is more like V0 and Bolt New and these online app creators. Okay, interesting. I'll check it out at some point, but it doesn't help us for creating our own coding agent. So, GPT Engineer, Codex, small developer. I'm not really sure about this, nor this one. So, modifying an existing coding agent, this would necessarily imply that we use the same language as the coding agent. I believe OpenDevin to be a Python and this one TypeScript. Either is fine. I mean, we have one of these. We can use Copilot for any language. Really, the choice of language doesn't matter that much anymore. Although I would prefer TypeScript to Python just for global warming. So these are the three options, and I was expecting a few more options. Do you have any other options to suggest that I might have missed? Nice. Use a notebook agent. Jupyter. LLM cell control. No. Terminal-based TDD assistant. We are talking about a terminal-based one. Or maybe not even terminal. We don't even want to give it a UI. We're just going to drive it from the tests. Browser-based. Oh, why? Okay. ChatGPT 4.0 is not the best software architect out there. Prompt only TDD agent, no code, all prompting. Strong prompt template that tells GPT-4 close to the. Yeah, so I've spoken to Ken Beck before this exercise, and he told me he already tried this. He managed to get some mileage out of it, but it doesn't seem like a proper solution, and we really want to control the loop. GitHub Copilot Chat scripted wrapper. Okay, this could be a possibility too. So this is really a variant of the option number 2. So we're still using a coding agent, but instead of using these CLI coding agents, instead we would be using an IDE integrated coding agent, which means we need some way of driving, of clicking the buttons in the IDE. Seems like an overkill, so I would suggest we just skip this. So between the solutions that ChatGPT suggested, I would discard all of them. They're either included in these three architectural options, or they are just don't make sense. So using a coding agent, I think this is the one we're gonna go for, because it's the easiest one to implement, and once we fail we can switch on to this one. This one doesn't really sound like an afternoon project, so this is a more significant time investment. Okay, so now we have a README file, and we want to create some agent that, given a feature, or given a feature and a code base, produces another code base. Code base being a folder with files in there. Now, do we want to make the agent always start from a blank workspace, or do we want to be able to implement feature number 2 or something like that? I would say let's always start from a blank workspace, because it just simplifies our problem. It's not that useful in real life, but this is just a proof of concept. So let's see. Using a coding agent for individual steps, if we want to do that, we probably want to, let me have a look whether we should go with Claude Code or OpenAI Codex. So Claude Code, here it is. Yes. Okay, getting started. npm install. Okay, we'll need npm, and that whole environment. Claude summarize this project, init, common tasks, fine, and CLI usage. This is the one we're interested in. Of course, SDK also sounds interesting. We're going to have a look at that. So CLI usage, we can always start the process and just capture the output. Or maybe we can use Bash for our coding agent, and then we don't have to worry about managing processes. Okay. Query. One-off query. Right, so this sounds like an interactive mode. Yeah, REPL. Okay. Yeah, this is the one we're interested in. Cool. Continue most recent conversation. Blah, blah, blah. Okay. And then SDK, basic SDK usage. Which is essentially, okay. Essentially, it's just the -b thing. Alright, plus continue. I suppose this allows for some context caching. That's alright. We could use something like this, but I wouldn't use it from the start because I'm not really sure whether we're gonna mess up something, and we might waste a lot of time tracking the session, etc., etc. So maybe we'll just spend a little bit more. And although Claude Code can be expensive, because it just starts burning. It starts performing a lot of interaction with the LLM and making a lot of API calls. So, oh, look at this. Bash. Yeah, definitely Bash is an option. Yeah, it could easily burn throughout a few $dozen. The first time I used it, I think it consumed a few dollars on a single prompt, and it was just a simple feature to implement. So it didn't seem to me, on a first impression, it didn't seem to me like very cost efficient. Although settings, this would be interesting. I would like to see whether we can choose the model, because if we can choose a slightly dumber model, we're not that interested into making the cutting edge coding agent. We're just interested to see whether TDD, a coding agent TDD approach, is better than a straightforward approach or code first approach. Monitoring usage. Okay. Track your costs. Yeah, sure. Okay. Claude Code is a viable option. We know how to use it. There's the -p thing. And now let's have a look at OpenAI Codex docs. UI. I thought it was, yeah, CLI. Here it is. This is the one I'm interested in. And codex -m model. Okay, we can specify a cheaper model, but it seems to enter in interactive mode. Experimental technology, maybe. provider. Oh, can we use? Well, we can't use any of the serious competition, so no Anthropic, no Google. Oh, Gemini is here. Okay. All right, and let's see. Do we have a prompt mode like just a single? Oh, there it is. Non-interactive quiet mode, -Q. That's it. Okay, so both OpenAI and Claude Code seem to fit our needs. And let's quickly have a look also. Do we have any API that we can call? And by API I mean just no, this is the tool used by the agent. We don't want to allow it to use tools, we just want it to generate code. We will be using the tools. Okay, so essentially we could use either one of these. Let's start with OpenAI Codex first. Let's try that one, and if that doesn't work, let's go switch to Claude Code. I'm suggesting OpenAI first because I hope it doesn't cost as much as Claude Code, but maybe I'm wrong, but either one should be fine. So they're both written using TypeScript. So what I'm going to do is create a dev container configuration. So configuration files in workspace, and I want Node.js. Let's have TypeScript too. Okay, Node.js, ESLint, blah blah blah. Okay, quite a lot of stuff. It's one of the official ones. Yeah, will do. Should I add bun? I'm not really sure how safe these things are, but yeah, it's running in a container. At worst, it will mess up my project. Okay, and now we open this thing in the container. Alright, we've set up the dev environment. Almost. Let's have a look now. npm pnpm. Oh, yes, it's here. Done. Nice. So we have a selection of whatever we want to use. And since we've made some modifications, so this is listed architectural options, and also added dev container config. Let's push it to the repository so you can see the code yourself if you want to. Okay, so next thing we want to do. Oh, do we have a viewer, or is this me? Hello? It could be just that it's counting me. Okay, in case you're joining it right now, what we're doing is we're writing a coding agent which follows TDD. And we've looked at several architectural options, and we've chosen to do it by reusing one of the existing agents. And the existing agents are, we're looking for command line agents because they're simpler to invoke, And we could use either Cloud Code, which is fairly straightforward to install, or we could use OpenAI Codex, which I believe is as easy as, yeah, same thing. Okay, let's go with this one. So we're running within a container, and we're now installing OpenAI Codex, which is a coding agent which will help us with a couple of steps of the TDD loop. So here's the loop. These are the 4 steps that we need to do. And the next thing that we need to decide, and this is another important decision, is how we're going to loop through this. So the simplest thing would be, okay, let's write a while loop and loop until it's feature complete. But there's another aspect to this, which is what if we fail, or what if we end up down a dead alley? Well, in that case, we need to revert. So we might to have something like an evolutionary algorithm, which creates a whole tree of versions of the workspace and then navigates that tree and works there. And basically the nodes of the tree would be steps or sub-steps of these steps. But that does sound complicated for a POC. So I don't know, maybe refactor it later in something like that. I would start with a loop, with a simple loop. Okay, we installed this, and actually the easiest thing to do right now is just to start with a bash script. We can switch to TypeScript or something else, but for the time being a bash script is all we need. And we're gonna call it TDD.sh for lack of imagination. And here bash, let's be optimistic, or probably should do something like env bash or something like that, but yeah, I think this is enough. Well, TDD plus x TDD. Okay, echo hello world, yeah. Okay, so we need to iterate over these 4 steps. So let's just paste this here and make it a comment. Right, so while nice. Okay, while true, do, done. Okay, this is all wrong, but we can definitely use it. And this is not while true. What I would want here is while feature complete, feature not complete. Can we do something like this? Yeah, I don't remember all these things in bash. I've done plenty of bash scripting, but I can't remember exactly how this works. So let's try this function. Nice. Feature complete, yes. And or even better, we're going to do feature complete equals false. Yeah, that's correct. And then while not feature complete, okay. Fantastic. And we're going to call the functions here. So function number one, function write failing test. Yeah, sounds good. Write failing test, and write failing test should affect the workspace, but it should also return something, and what it should return is whether we're feature complete. So for example, if we read the code, the tests, and we read the description of the problem, then if the LLM can't find any more tests to write, then the write failing test should return true, and basically we can say that the test has been completed, that the feature has been completed. So feature complete, maybe, or maybe not. No, we should. Sorry. No, we need something like this. Is feature complete, return 1, while not feature complete, like this. Let's try this one. Okay, what did I mess up here? Well, hopefully we have a coding agent to help us write the coding agent. So fix, and I also want to pass the terminal last command fix. Yeah. Oh, that was in ask mode. Okay, fine. We're just going to do this. Oh, no, not this. Stop. Sorry about that. Apply editor. So this apply editor, this is specifically the feature that I want to avoid re-implementing, because it sounds like something that's not trivial to implement. Okay, so let's Raul. Hey man. Good to see you. So, what we're doing right now is trying to create the basic loop of TDD. Yeah, that is live. It is live. We're trying to do a TDD coding agent, and now I'm trying to write the basic loop. And this basic loop has to iterate until the feature is complete. So now the feature complete, I'm just going to return 1, and this will probably this is false, so it will loop infinitely. Okay, let's see if this indeed loops infinitely. Yeah, it does. Okay, so now let's start adding the various steps. So we have we need to write a failing test. So function write failing test, and now it's the moment when we want to start invoking the underlying agent. So we're going to use Codex, OpenAI Codex as the underlying agent. Let me sure that it's here. Yes, it is. I need an OpenAI API key, so just a minute until I grab that. OpenAI API key. Okay. Alright, create new secret key, TDD kata. Right, copy. Now I need to do this off screen. Export OpenAI API key. Okay. Seems like I've copied a little bit more than the key. Ah, it actually is part of the key. Okay. Now, Codex. Alright, seems to be working. It's picking up the key and it's asking me for a prompt. I'm going to exit because we don't need to run it this way. Instead, what we need to do is run it in a non-interactive mode. So we use the OpenAI CLI thingy. Codex, explain this code base to me. Let's try it. Codex, explain this code. Dyslexia. Code base to me. Okay, so yeah, it is spamming the OpenAI API with requests. Hopefully I won't run out of credits. Usage. Okay, I won't run out of credits. It will charge my card directly. Okay. Purely scaffolding, script, minimal placeholder for the TDD cycle. Okay, yeah, that's good. Alright, so it works, it can invoke the API, it has fuel, and now we're actually going to start invoking codecs from the script. So first of all, we need a prompt. Now let's get the prompt. Our prompt is going to be essentially the first argument, right? So echo user input prompt. Oops. No. Okay, and I think I just managed to display the API key on the screen, which means this video will have to be edited. But that's fine. Or I'll just disable the key after I finish streaming. TDD. Oh yeah, there was no input. Write a Roman numeral parser. And no, it's not picking it up. Why not? No. Oh. Okay. Yes. Okay. Let's resort to agent. Should be alright. So it's not picking up the first argument from the command line for some reason. So yes, I installed codecs in the the backticks. Let's see. Thank you. And okay, what did I mess up now? So yes, Raul, you're following the right way. It's a series of codecs invocations, but we want to force them in a TDD loop. So, and by the way, I've spoken yesterday, a couple of days ago, to Kent. I've also asked Steve Freeman if he wanted to join. Kent was busy over the weekend. Steve didn't answer. Probably was busy as well. But you know, it was worth a try. But I think they'll be following this. They'll be interested to know the results. Actually, Kent already tried something like this before, but he was only trying to change the system prompt of one of the existing coding agents to explain the whole TDD loop and ask it, can you please follow the TDD loop? I'm going to actually force the agent to follow the TDD loop and please ask it to modify the files. So, where were we? Yes, it's not picking up the prompt because I'm not able to write. Okay, I think I've just pasted. Yeah, this is completely messed up. The code. Bash. Yeah, these things happen when you wipe code, and yep, seems to be working now. Much better. I thought this was what I written the first time around. Maybe I didn't. Okay. So now we can do some prompting, some proper prompting, and let's start by doing this. First, we want to create a folder for the, not the test, but the project. And workspaces, new folder. So I would like here something like no date, time, maybe date minus the date. UTC, yeah, that's it, date minus U. No. Well. Oh, yeah, okay. I was being stupid. Right, so create a new folder, and we need to create also a couple of files. Now, if we were to do this properly, we would be asking the LLM to decide which files to create and which is going to be the test file, which is going to be the other file. But this is just a proof of concept, so we're going to make a very stupid coding agent, and we're just going to do a touch, and actually let's put this into a variable. So workspace right, and workspace and touch workspace, and let's make it a JavaScript project. So code.js, or rather index.js, and touch workspace there. Yeah, this is good enough. We're not going to do anything smart like install packages or anything. We're just solving katas. So our agent is just learning to code. So at this point, is feature complete? Let's keep it loop infinitely for the time being. We'll give it some logic later. But now we can actually simulate. We can actually invoke codecs. So codecs, and let me just check the syntax. I think the syntax is minus Q. Exactly, it's minus Q. And minus Q. And now we want, given the following user input, write the failing test. Oh wait, given the following user input, and the following tests. And here we're going to use something like this. Cut. Right. No, we need to be inside of this folder. So cd, yeah. Copilot knows. Cat test.js. And do we give it the implementation? By the book, we should be writing the test based only on previous tests, but in practice that doesn't really work, does it? So I'd rather go with, yeah, let's give it a test. And the following code. Write the test that fails. Okay. Let's try it now. And write a parser for Roman numerals. Okay. This didn't go according to plan. Well, one problem is we're not invoking write failing test. The other problem seems to be with creating these. Oh yeah, because it's not in the root. It's here. Ah, yes, of course, it's not inherited. Shouldn't it be? Well, let's see. Oh, interesting. There's a quick assist directly in the terminal. Okay. I'm invoking another process from my bash script. It seems that the envars are not being passed to the underlying process. Okay, I already did the export. Parenthesis in line 30. No, actually, for a function without arguments in bash, you can invoke it without the parenthesis. You can even pass the arguments like this, like in the functional languages. Yeah, actually, I've learned something a few years ago. I was looking at there was a colleague of ours, Alex Bruckner. He was really, one of the best coders that I've seen, and by reading his code, I learned to write good bash scripts, which probably you can't see it from what I'm doing right now, but at some point I was better at it, and he taught me to write functional style bash. So essentially composing these functions and using inputs and outputs to pass things to the functions and retrieve the output from them. And then you combine that with a tool like JQ to deal with complex I/O, extract fields, etc., etc. So yeah, it's Bash has become quite powerful again, and it can be quite modular, and you can actually write nice readable code with it, with these tricks. Although, you know, it's not simple. It needs a little bit of starting to think in that functional aspect, which I've always had trouble with, to be honest. Okay, so we're not passing the API key for some reason. I'm not really sure why this should be, but you know, we could do it like this for the time being. Let's see if this is paste, enter. Okay, and again, of course. And there is no such file or directory. Oh, rejected the request, so I probably passed and pasted in something else. Yes, I pasted in the workspace. Oh, yeah. Sorry, I need to do another off-screen move. Okay. So let me display echo OpenAI of course, this is the wrong prompt. Yep, we can go back. I was in the wrong window. So this is the prompt of Copilot, but this terminal is the right terminal. So write the Roman numeral parser. Okay, something's going on. Command not found. Okay, I think I'm gonna kill it now because I have no idea what's going on in the background, and here it is. And nothing is going on in the background. Okay, fine enough. It seems maybe like it's not properly changing the directory, although it should be. I mean, once we change the directory, this is applied, this is not bound to the current scope, so even if we're inside a function, this should still work. CD workspace there. Okay. Echo on, I believe. Oh, it's not echo on, that's DOS. Set the script to display every command on. It was set something -x. Okay. There you go. Okay, user input, write the Roman numeral parser, date, CD, workspaces, coding agent. Okay, index cannot touch, not such file or directory. But of course I'm being stupid. Or even better, let's do it like this. Okay, wait, I'm going to put the chat here because you're giving me a lot of valuable advice and I'm ignoring it. How do I make it? No, that's even worse. What does this do? Okay, I lost it. Oh, and here is codex burning through my through my credit card. Okay, let's see again. Okay, now we seem to have something. We have a test. Okay, empty test and index.js, empty index. Alright, so it seems like this isn't really working. Let's see what it's saying. Status completed. Write a test following. Write a Roman numeral. No, given the following user input, write a Roman numeral parser and the following tests and the following code, write a test that fails. Okay, and probably what we need to do is also tell it to which file in the test.js file. Yeah. And now it's not doing anything. And I also want to make it sleep a little bit longer so we can follow it. Oh, sorry, this one. No, it's still empty. Okay, so let's try it manually. Let's go into 20, sorry, to workspaces 20 715.16 coding agent codex minus q add a test for a Roman numeral parser. Oh, I cancelled it too early. So this is the inner loop of the coding agent that we're invoking. So we're actually using a coding agent as a single step of our coding agent, and this one has another loop, and it seems to be looping eternally. So yeah, nothing is changing. Okay, this is not very helpful. Wait, this is one of the two coding agents. Now we could try to convince the coding agent to modify a file. Let's see. Are there any examples? This is quite straightforward. Okay, so he should be able to modify the files right here. Instead, it's not doing it. It's not changing anything. Now, an alternative that we could do is just use Claude Code. So let's do this quickly. Instead of codecs, what we're going to do is, sorry, not here, paste, and then Claude Code has the -p option to do the offline, the single prompt, the non-interactive thing. Okay, and it's Claude. Let's try Claude. Sorry. API key. Right. Anthropic. API. Failed to fetch. Okay, it's not creating the API key for some reason. What if I use the default workspace? Okay, maybe this worked. And for this one, I need to export this as what? Okay, this seems to be working, although it's really silent. So we're here, right? 1620. Oh no, we're here, 1620. Doesn't seem to be doing anything. I've added comprehensive tests for Roman numeral tests in Parasite test.js. Okay, a test, not comprehensive tests. And 1620. 1620 should be here. Okay, for some reason it seems like none of the two agents are modifying the files. Can't be a permissions thing. I don't think so. Let's see. Oh yeah, thanks for the advice. And yes, please distract me, because it's quite boring doing this alone. And the .sh. Okay. Oh yeah, of course. Claude. Nothing. I need permission. So it does need permission. Okay, that seems to be the problem with both of the agents. Okay. Let's try this. So, well, no, let's do it properly. CLI usage and allowed tools disallowed. Okay, there's apparently a settings file. Okay, project settings, Claude settings. Right, permissions allowed. Oh, nice. That's it. Copied. So this is .claude settings.json. Oh, yeah. It has to be in the generated project, not in this project. So it's here. Claude. Fine. And another thing we're going to do is new file, Claude settings template.json, which is this thing here. Okay, and cloud settings template.json, and that's it. Let's see. Of course, the settings might be wrong. Bash read. I didn't want that. Given the following user input. Let's see. Settings, available settings. I'm looking for write. Edit. Yes. Want to edit everything. And I actually don't want nor this. Okay, I guess I can kill this. Kill. Let's do it again. Nothing's happening. Maybe it's slow. I've written a failing test. Did you? Yes! Yes! Okay. Requires oh, of course, we need the testing framework. Yeah, of course, I was... okay. Testing framework. Fine, we can install a testing framework. We need to set up the project, so it's... let's do this. npm init -y just I prefer vtest, and that might do it. Let's see. Package test, of course. We need to modify this. Now let's have a look at the test. Is it using? Yes, it's using vtest. Perfect. And index not modified. Fantastic. We're actually getting to the first step. Good. Okay. So, and let me actually commit this stuff. Right. So workspaces, ignore, and using code, and what else? Using vtest. Good. So the next thing to do is run the test. And running the test, we're going to do this manually. Run test. For now, I would pretend that running the test is something that we don't Oh yes, the other thing, I need to change the package.json. So we could do this. No. We could do something like this. Function setup test framework. Modify the package.json file. We could probably do this using awk or one of those Linux tools that I don't know how to use. Actually, you know what? Let's see. Use awk to modify the test script in package.json. Oh, I didn't say that it should be using vtest, but maybe it's that smart. Yes, it is that smart. Okay, let's do this once more. No, I didn't invoke it. Stop. Stop. And it would be nice to put this here as well. Setup test framework. So I plan to go on for about 20 minutes more, and then I'll probably have to resume tomorrow because I need to start preparing for dinner. But let's see if we can make at least another step. No test files found. Oh, of course no test files found, because you don't call it test.js, you call it index.test.js. Right. In the index.test.js. Fail. Yeah, that's it. Next step. Alright, so we have a failing test, and now we need to fix the test. Function fix failing test. Oh, okay, that was too easy. Given the following input and the following tests and the following code, write the minimum code to pass the test in the index.js file. Yeah, it's doing everything on its own. But there's one more input I want to pass here. So reporter verbose. Let's try capturing this. So I want to put this into variable. So test result equals this stuff here, and then echo test result, and I believe maybe we can return it as well. Okay, this looks nice. Maybe. Let's give it a try. I'm not really sure what it does. So, yeah, worst practices of vibe coding. Accepting code that you're not really sure what it does. But this is, oh yeah, run test. And here we test result equals run test. And now we invoke fix failing test with test result. And now, and here we can also use this syntax. I'm gonna do it this way. Now the proper functional way would have been to pass it as input, not as a parameter, but as input. So something like it would be run test and then pipe it onto fix failing test. So this was the, well, why not? Because we're already printing it. So echo test result and fix failing test. Fix failing test. Let's see. Read the std into a variable. I forgot how this used to work. The following test result I'm going to call it test result. Okay. Okay, this was the test result. It just got printed. Oh, it didn't pick it up. Oh, the minimum code has been added to make the test pass. Did we just complete the full cycle? Yes! Yes! It works! So I'm not really sure whether the package JSON is... Oh no, it's not. Yeah. On the positive side, we're not using it. I just realized a moment ago that we're actually invoking vtest directly, so we're not doing npm test, but vtest. So awk. Yeah. We're just going to skip this. V-test should be okay. And yeah, this seems to be working. Okay, now the last test. Or rather, I would try to put a termination condition. But termination condition, what would it look like? It's not an agent. I shouldn't be invoking an agent. I should be invoking maybe OpenAPI directly. So let's see. Is feature complete? Maybe I should be curling OpenAI, which would tell us whether the tests cover everything. So prompt equals, and did I use user prompt? I used this prompt. I don't want to use that. P equals, given the following user input, is the user input and the following tests. index.test.js. Oh, yes. Index.test.js and index.test.js. This worked only because we did one iteration, but probably with the next iteration it would still try to convert the number one. Okay, so with the following test, is the feature complete? Answer with 1 for yes and 0 for no. Okay, and yeah, now we need, would this work? Really? I don't know. I don't even know what is $? Exit value of the last command. But that's the exit value, not the output. We need the well, you know what? Let's give it a try. Let's see how this works. So while feature complete, done, and just to make this more noticeable, here. Okay, we're missing the refactor here. To do refactor the code, that's fine. Okay, 0. Okay, it's writing a failing test. Yeah, it's pretty cool. Okay, first iteration, let's see. right in the second test. Brilliant. V. I like it how it goes to V directly, and it's probably the best way to solve this exercise. Okay, so third test. Let's put the index on the side. Yeah, and it's actually smart. It's doing it proper TDD. So the minimum code that will make the test pass. Where's the test? Okay. Now, the question is whether we'll end up with an infinite series of if statements, or at some point the Claude will realize that it needs to refactor. No, it won't realize that it needs to refactor because we're missing the refactor step. Of course it won't. But let's see number 4. Yeah, we're trying a new Italian restaurant that opened recently here in Bar. Okay, so 4, it's using a literal, so it's not really introducing any proper logic. But still, it's following the instructions. It's doing exactly what it's asked to do. We're just missing the refactoring bit. So this is really simulating the TDD process quite well. Now, of course, this is a very simple exercise, and what I'm interested to see is how will it do when we ask it to, for example, write a chess solver, which is significantly more complex, and it needs to also start evolving the design of the application of the code under test of the 9. Yeah, it's just adding if statements. Although, to be honest, I've met several people who were doing TDD like this. Actually, most people that I've worked with when doing TDD would just add special cases without refactoring. And when they start refactoring, maybe it's too late because there's a lot of they already split the class in multiple classes. So definitely I've seen this horrendous if statements when somebody tried to implement complex algorithms using TDD. That's one of the things that I discussed with Kent. Is that refactor thing shouldn't be the 4th step. But then again, as he says, for somebody it is easier to reason once you have the code rather than do it abstractly. For me, for example, it's easier to decompose the problem, to formalize the problem and decompose the algorithm. But yeah, this is amazing. We're actually replicating the proper thought process and the proper errors that beginner TDD practitioners do. Okay, I think this is a good time to stop. Next time we're going to do stop. Next time we're going to do the refactoring step, which should be also straightforward. But what we're missing here, and this is a big lacking feature, what we're missing here is all the various checks that the inner loops. Sorry, Mimi. Hey, Mimi, how are you doing? So yeah, we've Mimi. Just to summarize what we've done, I'll continue tomorrow. I promise. I'll let you know when I start this. But what we've done is created this coding agent which uses TDD. It's something that I've discussed with Ken Beck, and I'm trying to get Steve involved too. And essentially, rather than just giving some system prompt to an agent and telling it to use TDD, we're actually writing a loop. So here is the loop. While feature is not complete, write failing test, run the test, fix the failing test. We're missing the refactoring the code step, and then iterate over everything until the feature is complete. Now, without the refactoring the code, this is the code we get. What we're missing is within each of these steps, we actually need to have a loop that makes sure that when we write a test, that the test is properly failing, or when we fix the failing test, that we've really fixed the test and that we didn't break anything else. For an example like this, it's trivial, but once we start dealing with more complex problems, we should start really doing the checks. So there will be, each of these steps will be a smaller loop with a smaller inner loop, which says, okay, try fixing the failing test, and if the test still fails, then we try again. And there is another concept that I wanted to explore there, and this is really to try an evolutionary algorithm, which I've already experimented on an AI game that I was working on. But essentially, every time we make a new step, we create a version, and we organize these versions into a tree, because we can traverse the tree downwards, so linear progression. But if we see that we're stuck, we can go back, and we can go back one step, but we can go sometimes even multiple steps, because maybe the tests we've written was a test that has some conflicting requirements. So at some point, maybe we want to, rather than trying to fix the failing test by modifying the code, we actually want to rewrite the test. So that's how we end up with this tree structure. So that's another thing to explore. But I think the most important thing, the next thing that we're going to do tomorrow is to refactor the code, and after refactoring the code, to introduce these inner loops, just to make sure that each step that we do has completed successfully, and if not, retry it. And then if after a number of retries we still fail, then abort the whole operation. But yeah, that's pretty much the summary. I'm really happy with the results, really excited. I'm looking forward to see once we make the algorithm a little bit smarter, and given that this is really using Claude Code underneath, so one of the top coding agents out there, I'm really looking forward to see what are the capabilities of this approach. Is this actually better than using out-of-the-box Claude Code? So yeah, thank you for watching, and yes, I'll let you know tomorrow when I start streaming the second part of this. And thanks for the help. Bye!